In this experiment, we're going to find the density of some regular objects, some irregular objects, and some liquids. First, you'll need to collect the equipment that you're going to use. A top-pan balance, a vernier caliper or a ruler, one measuring cylinder, a eureka can, and some objects we can measure the density of. First, let's work out the volume of the regular-shaped objects. Measure the length, depth and height of the cube to the nearest 0.1 of a centimetre and record it in your table. Calculate the volume by multiplying all three quantities together. You may use the electronic vernier calipers to measure these lengths. But be aware it gives the value in millimetres, so you'll need to divide by 10 to get this value into centimetres to record in your table. You can use a top pan balance to find the mass. Make sure you zero it before you use it. When calculating the density of a liquid, finding the volume is straightforward because we can use a measuring cylinder. Make sure you get down to eye level so you can accurately read the value from the bottom of the meniscus. However, finding a value for the mass of the liquid is more difficult because we need to disregard the value of the mass of the measuring cylinder. However, similar to what you might do in a food lesson, you can zero the balance, then add the liquid to the measuring cylinder, and the value shown will just be that for the liquid. Now to calculate the density of an irregular object. As long as you remember to zero the balance, measuring the mass is straightforward. Record it in the table. There are a few ways to measure the volume. One requires a eureka can. Fill a eureka can to the top, being very careful because some should overflow down the spout. Now that the water is level, hold a measuring cylinder under the spout and then dunk your irregular object so that it's fully immersed. The amount of water that overflows from the eureka can down the spout is the same as the volume of your object. Record these values in your table and calculate the density. If you have time, repeat with some more objects so that you get at least 5 sets of results. Good luck!